So we're going to be doing the Lewis electron structure of sulfur dioxide. So first we need to know the valence electrons it has. So sulfur has 6, each oxygen has 6, and there's 2 of those. So altogether we have 18 valence electrons. And then when we're drawing our diagram, we're going to put sulfur in the middle since it's the least electronegative. Then we're going to have our oxygens on the outside. And then we're going to start distributing our valence electrons. We're going to start with 2 single bonds, and then that gives us 4. Then we have 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and we're going to add the last 2 to sulfur. Now that we notice that our oxygens both have 8, but our sulfur only has 6. So we're going to take away one of these and add a double bond there. And now, since sulfur dioxide is a structure, sulfur can hold more than 8 valence electrons because it's a period 3 element. So we're going to calculate the formal charges to see if this is the best structure that we have. So the way to calculate formal charge is to have the valence electrons subtracted from the dots and sticks that we have. So for the single bonded oxygen, there's going to be 6 valence electrons, and then there are 6 dots and 1 stick, so we're going to -7, so that's going to be a -1 formal charge. Then our sulfur is going to be 6, and then we have 5, so that's going to be a +1 formal charge. And our double bonded oxygen is going to have 6 valence electrons -6, which is going to be a formal charge of 0. And now that we look at our formal charge and all of these are not 0, that's going to suggest that we need to try a different structure. So if we redraw this, a different structure could be the sulfur with the oxygens, and instead we're going to take one of these and we're going to add a double bond there, and that's going to be a different structure that we could use. And now for our formal charges, we're going to calculate those, and this will be 6 minus 6, which equals 0, which this one will as well, and so will this one. And since all of them are 0, we know that this is the best Lewis electron structure for this compound, and our electron pair geometry is going to be trigonal planar. Because of this lone pair, there's 3, and then a lone pair. Because of the lone pair, there's going to be a molecular geometry of bent, and this bent shape is represented by our 3D molecule here, and it's going to be a polar molecule because on the bent shape, there's the 2 lone pairs, so it's not symmetrical here. So there's going to be, and sulfur has a partial positive, so we're going to have 2 poles, and the oxygens have a partial negative. So there's going to be 2 poles, so it's going to be a polar molecule.